Good afternoon to all of you, my dear students. Let's start today's session, which is transport layer. So we are doing CCNA-1 Introduction to Networks. And so far we have covered 13 chapters. This morning I did ICMP. And now we are going to do transport layer. You have done transport layer 1 and 2 in your lecture, and what you have studied is in detail. Over here, we'll be touching the surface of transport layer with regards to your communication, okay, and the main two protocols associated with it, TCP and UDP. Of course, in the lecture, you went into the details of those algorithms. But here, we will just touch on some of those. We won't go into details. So, the objectives is, why do we need transport layer in the first place, okay? How does it ensure end-to-end communication? We will look at the characteristics of transport layer, specifically in form of TCP and UDP, because those are the two most important protocols in your transport layers. We'll also look at the importance of port numbers in TCP and UDP. We will look at how TCP sessions are established and terminated during communication. We will also look at reliability and flow control with regards to TCP, because that's something TCP guarantees. UDP does not. UDP's main focus is speed, okay, rather than reliability. We will look at UDP and compare the operation of transport layer protocols in end-to-end communication, specifically TCP and UDP. First of all, if you look at the OSI model, you will look at transport layer being right in between the top application layer, okay, and below that the network layer, data link layer, and presentation layer. So it's like really responsible for transporting your data to the application. Okay, it's what stands between application and the lower layers. Okay, so its main task is communication between the different hosts and being an interface between application and the internet. In OSI model, as well as your TCP/IP model, okay, it has got that function. Okay, doesn't matter which device you're using, smartphone, a computer, IPTV, or an IP phone. Okay, so it's responsible for that logical communication, and it's a link between the top layer, okay, application, as well as your bottom layers. It has got certain functions. If you look at it, it looks at the most important function is segmentation, taking your data and segmenting it and giving that segments to the network layer below. Or it comes the other way around. It takes those segments and reassembles them into proper order and gives it up to the application layer. Okay. When it creates segments, it adds header information. It can make sure that multiplexing is happening, how you can divide these different messages into different conversations. Okay, you must have studied in your lecture why we have multiplexing. Okay, the whole idea of multiplexing is sending your messages through different frequencies. Okay, so if you have got different frequencies, that means frequency 1 to frequency 10, for example, is one channel. Frequency 11 to frequency 20 is another channel. Okay, what is the benefit of this? the benefit of this is you can send multiple signals at the same time. How do you think your internet, your voice, your video, your audio, everything is happening at the same time? Okay. I can talk to you right now using our WebEx video conferencing. What we can do at the same time, I can get a phone call using the same connection and talk with someone else. How is that possible? Because of multiplexing. Okay, you have studied this in your lecture. We also studied about segmentation. Okay, and that is one of the properties of your transport layer. Okay. If you look at your transport layer, you will see that it is responsible specifically for two protocols, that is your TCP and your UDP. On the surface of it, if you want reliability, use TCP. If you want speed, use UDP. Okay. So here, it does not give you the details of delivery or transportation of the packets. For that, you have to use TCP or UDP. Under transport layer, it specifies, okay, how to transfer the messages between hosts. Okay, so we're going to today actually we're going to look at more at TCP and UDP, because these are the two main protocols associated with our transport layer. If you look at TCP, it provides reliability and flow control. Flow control means if the connection is good, send more. If the connection is bad, send less. Okay. So when it creates the segments, what it does, TCP, it numbers and tracks the data segments. Okay. And every segment sent is acknowledged. If there is no acknowledgement, the segment will be retransmitted. You see, the key word for TCP is reliability. And every segment has got a sequence. And when you send it, it will arrive in out of sequence, and it will arrange it into a proper sequence and then send it up to the application layer. Okay. It will also ensure that data is sent at an efficient rate. If there is a bottleneck, like I said, decrease the flow. Okay, remember your sliding window? You have studied that in the lecture. So, if there is no bottleneck, then send more. Okay. On the other hand, if you look at UDP, you'll be surprised. It's very much different. Okay. UDP has got only one function, and that one is best effort delivery, because we are looking for speed. Okay. It sends the datagrams in a form which is connectionless. Just send it. We don't care. Best effort. Okay, that's why I call it best effort. No acknowledgement, my dear students. No acknowledgement. Okay. Now you would be asking, why do we have UDP? What's the point? Because sometimes we need some applications. They need best effort. Reliability is not important. Okay, we'll be looking at some of the applications that use that. Reliability is not important as long as you have got a real-time connection. That is important. Speed is important. Okay. And the benefit of this is it creates very little overhead and data checking. Okay. Because every time you do this acknowledgement itself, you have to wait for the acknowledgement to come and so on. So UDP doesn't do that. Okay. So you have to ask yourself which application is going to use TCP and which one is going to use UDP. So here we are. Applications like voice over IP domain name system, they use UDP. Applications like emails, SMTP or IMAP, HTTP and HTTPS, they use TCP. Okay. Some applications, they need to be fast, low overhead, no need for acknowledgement. You don't need to send lost data. And it doesn't even arrange the segments. Okay. If some data is lost in voice over IP, it's okay, no problem. Just carry on. Okay. But in HTTP and HTTPS, no, it's not. Okay. So you have to, depends on which application you use. Okay. You have these two protocols that you can use as per your application. You have to also understand that some apps, they use both. Okay, there are certain features that they use both. Now let's start with TCP. Let's look at TCP and understand it better. Okay, as we discussed, TCP has got very good features in first, it establishes a session. Okay, a sort of a circuit before you send your data. UDP doesn't do that. Just send the data. Don't care about the circuit. Okay, you establish a session first in TCP. And you send your segments, you send your data, and if you don't get an acknowledgement, you send it again. Okay, so remember, establish a circuit, acknowledgement. Okay, the segments have to be numbered. If you send a segment in 1, 2, 3, in the receiving end, it will arrange it as 1, 2, 3. Okay, and when you send your data, if your network has bottleneck, send less. If there is no bottleneck, send more. Okay, control the window size of sending as your flow control. So these are some of the features which are very good as far as TCP is concerned. Okay, this is the TCP header consisting of your source port, destination port. Okay, if you look at it, it consists of 160 bits, which is actually your 20 bytes. You can see that it has got acknowledgement number, sequence number, because sequence as in the segments have to be arranged in a proper sequence. Okay. Header length, reserved bits, control bits. We'll be looking at what are the 6 control bits. Okay. Each control bit is associated with a number. The window size, the checksum to make sure that data is sent. An urgent flag if your message is urgent, and so on. Okay, the details of it is given over here. These are the header fields: source port, destination port, control bits, urgent, and so on. Okay, now I won't go into details of this. You can go through it yourself. Okay, so these are the TCP header. You can see it's very bulky. Now think about your UDP header. Do you think it will be bulky like this? Do you think it will be 160 bits? No, it will be much more lighter. Okay, because it doesn't need certain aspects. It doesn't need sequence number. It doesn't need acknowledgement. Okay, but TCP, it guarantees reliability, so it needs all these. Okay, TCP handles all the tasks associated with taking your data and dividing it into segments and then sending those segments in proper order. It may be garbled at the receiving end. At the receiving end, it will take that number, you see the segment number that we discussed, the sequence number, which is associated with your segment. It will take that, arrange it, and give it to the application order, to the application layer. See, that's what it does, reordering segments. And these are the protocols it takes care of: HTTP, HTTPS, FTP, SMTP, and your secure shell. Okay, if you remember, this is what we use for encrypted communication. Okay, so that nobody, even if somebody sniffs our packets, They won't see what we are typing. It's encrypted. So these are some of the features of TCP. Now let's go to UDP and see what it looks like. In UDP, as we see, data is reconstructed in the order that it is received. If the segments are garbled, if instead of 1, 2, 3, if it receives a true 1, 3, it doesn't care. It doesn't rearrange it. If a segment is lost, no worries. It doesn't care. Okay? If a segment is lost, no acknowledgement. Just it will carry on with that. Okay? No session, there's no circuit establishment, no session establishment. Okay? So these are the features of UDP. Yes, no reliability is guaranteed, but speed is the essence of this UDP. Okay, now look at the UDP header. Only 64 bits, only 8 bytes. All it needs is source port, destination port, okay, length, checksum. Okay, and that checksum is not for acknowledgement. You see, that checksum is a 16-bit field used for error checking of the datagram header. That's it. Not for acknowledgement, okay? So you get an idea that, UDP is actually for speed, not for reliability. So where do we use UDP? There. If you have live video, okay, and multimedia applications, then perhaps you can use your UDP. If you're using your DHCP to get your IP address, DNS, SNMP, okay, trivial file transfer protocol, voice over IP, video conferencing, okay, all of them are using your UDP, okay. Many applications use features of UDP as well as certain features of TCP. Okay. Now you will be thinking, does our WebEx use pure UDP? Not really. There are aspects of TCP involved in it. Okay. You have established a session. So it's a sort of a mixture of both of it. Okay. And you can actually, when you design an app, you can program this using programming languages like Java. You can actually program an app to take advantage of all this. And here there is a class in Java where you can mention whether you want to use perhaps your UDP or TCP components or both. There is another important aspect with regards to your transport layer, and that is port numbers. Okay. Now you may ask, why do I need port numbers? Because when you're accessing a computer, a server, you're not accessing only one service in there. You may access different services. So how can one server give you different services? Answer is by following different port numbers. Okay. So both TCP and UDP use port numbers so that you can do things simultaneously, multitasking. Okay. So you have got source port and destination port associated with your connection. Let's say if this is one user and this is another user, if you take into account the source port and the source IP address, we call that, okay, a socket. If you take into account your destination port and your destination IP address, that is also one socket. This is one socket. Okay. Another tip, in Java, we have got socket programming. Okay. So all these features Someone's microphone is switched on. Can you please switch it off? Thank you. So sockets, who's that? Sockets enable multiple processes running on a client, okay, to distinguish themselves from each other. You can also have your, for example, over here, look over here, FTP client source port 1305 communicates with the FTP port, which is 21. Web client, doesn't matter, this is not a famous port, but using this port, it communicates with port 80. Port 80 is famous to be our HTTP port. So the same server can give services based on 2 ports, FTP service as well as web server service, okay? If you look at your well-known ports are from 0 to 1023. Registered ports are between 10242, 49,151. And if you want to register, you have to communicate with Internet Assigned Numbers Authority, IANA. We also have private or dynamic ports. Now, these ports are ephemeral. Ephemeral as in transient, that means temporary, okay? So you can also have this range. But well-known ports is what we are interested in. And you see, these are some of the famous port numbers, 20 and 21 associated with your FTP. Okay? Establish a session, send your data. AT is the most famous associated with your HTTP. Okay? And so on. So these are some of the ports associated. Telnet is 23. But Telnet is not secure. If you want secure and encrypted, then use SSH, secure shell, then use 22, and so on. Okay. Sometimes your device or your computer may have unexplained TCP connections. So one of the commands you can use to isolate that is your netstat command. Okay. Okay. I'm not going to run this on my computer right now because I don't want to see the links that it shows. Okay, but you can run your netstat command. Okay, and it will tell you what are the ports and what are the TCP connection that are accessing your machine. Okay, if your computer is specifically slow, what you can do is run this. If you have a torrent like BitTorrent, open your BitTorrent and then run this, and then it will show you all the connections. Or if you are doing mining on your computer by using a mining software, run that mining software and then run this. It will show you the connection to all the computers that are accessing your PC. Okay. Yeah, it's amazing. It's amazing tool. Okay, netstat. So whatever unexplained TCP connections you have, somebody is accessing your computer, you can use your netstat to isolate and find out who are they, from where they come, and what port they're using to connect to you. So how does TCP communication happen? What is the magic involved? How? What is the process? Let's have a look. First of all, each application process is given a port number associated with it. Okay? You cannot have 2 services with the same port number. It has to be different. That is how this server, okay, that is how this server will ensure that 2 services are given. One is HTTP service, and the other one is SMTP service on different ports. So no problem. This one will access one service, which is it wants a web page. So that web page will be given to it. This one wants to get its email. So what it's doing is working on port 25. Okay. Now, it may access these ports by using its own source port. Now, these source ports are established. Now, these are its own source port. But the server's source port, these are the standard source ports. For SMTP is always 25, and for your HTTP is always 80. And based on these requests, the server will assign the data or the information they requested for. If you look at the TCP connection, the three-way handshake, this is what it looks like. Okay. First, it sends a SYN. Okay. You remember we studied that the TCP flag control bits consist of 6 flags. Okay. Now these are one of the flags, SYN. Okay. ACK. We'll be studying that. Okay. There are 6 flags. So what happens is, the first thing is, let's say it wants to establish a connection. It sends a SYN, okay, to synchronize. Okay. So you see here, sequence is 100. CTL, as in computational tree logic, is equal to SYN. It will be send. And let's say the SYN is received by the destination. Then the destination will reply to this SYN. Okay, it will send a new sequence 300. It will acknowledge this one. Okay, and then CTL is still SYN and will send the acknowledgement back. It will be received. Once it is received, the third part of the handshake, sequence 101, will be sent, acknowledge the 300, and CTL is equal to acknowledgement will be sent. And that's how the handshake has been established. Remember, the first part of TCL is circuit establishment, session establishment. Here, you have established a session. Now you can send your data. Okay, remember, TCP reliability. First, establish the session. How? By using these 3 handshakes, three-way handshake. How do you cut the session? Again, if you want to cut the session, you have to follow a certain order. You send FIN. Okay, remember I told you there are 6 control bits. SYN, ACK, FIN, and so on. Okay, we'll be going through that. Look, if you want to stop the session, you send the FIN. Once it receives your FIN, the destination, it will send the acknowledgement for that FIN. It will send its own FIN as well. It will say, hey, I'm also sending you a server FIN. And then you acknowledge this FIN. Now, the session is terminated. The circuit is broken. It's like dialing a number. Okay? So this is how you terminate a session in TCP. Okay? Following that 3-way handshake. So following the 3-way handshake, first what you have to do is you have to first establish that the destination device is present. If it's present, you have to have this active service, and it is accepting your request on the destination port number. Okay, and then you inform the destination device that the source client intends to establish a communicational session on that port number. And once that is accepted and acknowledged, the session is established. And once you have finished, you can stop the session by sending a FIN. Okay, you can close your session. Okay, and that close, as we saw earlier, and that close has to be acknowledged. The server also will send a FIN message, and the sender will acknowledge that FIN. And then the connection is closed. Okay, all this will enable your TCP to have reliability. Speed is not important, but reliability is important. Okay, now these are the control bits, flags. Okay, we have got urgent, we have got acknowledgement, we have got, you see, in addition to this urgent, we also have another urgent which is separate. Okay, we have got push, we have got reset, we have got SYN, we have got FIN. Okay, so these are our 6 control bit flag, and depending on which number you use, it associates with these flags. Okay, another feature of TCP that I told you is reliability and flow control. Okay, now how does TCP establish that? Let's have a look. One feature is that whatever segment is sent, it is ordered. Okay, this ordered delivery is guaranteed. Okay, now you may ask, hey, I've studied that when the segments are sent, the segments are converted into packets, packets are converted into fragments, fragments into bits. When it reaches the destination, of course, it won't be in the same order. So if you send it in this order, it comes in a garbled format, no problem. Your TCP will ensure, by looking at the segment header, it will look and arrange it according to proper order, just like how you sent it. 1, 2, 3, 4, 5, 6. It will take this and arrange it as 1, 2, 3, 4, 5, 6. So if TCP segments do not arrive at their destination or arrive out of order, these segments will be reassembled into the original order. And this is very common because you know that when you send your segments, the frames, the packets will be taking different routes. So this is a common occurrence. So TCP has got a function to arrange it in a proper order. Okay. How does this magic happen? Because every segment has got a sequence number associated with it. And based on that sequence number, it can know this segment belongs to which message and what is the sequence number. Okay. And depending on which segment you send, okay, remember TCP, reliability. Okay, we are talking about reliability. Depending on which segment you are sending, if any segment is lost, retransmission. Okay, so if you send segment 1, segment 2, and then segment 3 and segment 4 for some reason are lost, your acknowledgement you will get for 1 and 2, but 3, no. So what it does is, again, it sends starting from segment 3. But if you observe this, something which is not efficient is our 5 to 10 segments we had already sent, but it's going to send it again. So what you have is duplicate segments. Okay, so this is the inefficiency. When you send duplicate segments, you're slowing down the network. Okay, so there is a way to get over it by using SAC, okay, or selective acknowledgement. How? Let's say segment 3 and 4 have not been sent because of network failure, a router failure, or anything like that. So what happens is you get your acknowledgement for 1 and 2, and then 3 needs to be sent. And then you can also send a selective acknowledgement that, hey, from 5 to 10, I have already got. So now the source knows that it has to send 3, 4, and then not 5 to 10, but it will follow with others. Okay, following 10, perhaps 11 and 12. So this makes it much more efficient, okay, and makes your TCP much more faster. Okay, of course we guarantee reliability, but we also make it faster. Okay. Now, if you look at your lecture, you go into details, algorithm details in your lecture. Here we're just touching the surface. Okay. Another thing that you do is flow control in TCP. How do we do that? We do that by having a window size and a MSS, maximum segment size. Okay. So we can start, for example, with the window size 10,000. And segment size, we can start with 1460. Now, how do you come out with 1460? We'll come to that later. Okay. So we start with 1460 bytes. Okay. So the destination will tell the source that this is your size of the window, that amount of data that you can send. You can start with chunks of 1460. So it will send the first sequence number 1460 bytes. It will be received. Then it will send the second one. So you receive 2920. And then you send the acknowledgement for that. Okay. And since there is no problem, the data has been sent, the window size is increased. Okay, from 10,000 to 12,920. Then it will send the next one. It will increase from 2920 to 4380. Okay, since there's no problem, acknowledgement will be sent, and then this will be added, and the window size will keep on increasing. So you keep on increasing the window size until there is a problem somewhere. Then you again decrease the window size. Okay, you have studied this in your lecture as well. Okay, one of them is your sliding window. So based on that, TCP ensures that your flow control is maintained. If there is a bottleneck, it will decrease the window size. Okay, that's what you can ensure reliability with the help of your TCP. Okay. Now, why 1460 bytes? It's very simple, because your actual bytes by default is 1500 bytes. Okay, but it has to take into consideration the value of its MSS is not exactly 1500, because it subtracts the IP and the TCP headers. Okay, so the IP and the TCP header, 20 bytes and 20 bytes, will be subtracted from your 1500. So we come with 1460 bytes. Okay, so that's how it comes with that. If any segment is lost, okay, the acknowledgement will be sent for the segment that has been received, and the one which is lost, it will ask to send that segment again. And the window size will at the same time decrease. Okay, it will go down. Okay. Here it tells you, to avoid and control congestion, TCP employs several congestion handling mechanism, timers, and algorithms. You see, in your CCNA, that's not the focus. We don't go into details of algorithms, but in your lecture, you do. You study that. Okay. Now let's look at UDP, best effort communication. Okay. Remember, in UDP, we do not care about reliability, but rather we care about speed. Yes, no need to establish a connection. Low overhead. Okay. Remember the header? It doesn't have all those luggage with it. Okay, so it will just send your data, and whether the data is received or not, we don't care. Okay, there it is giving you one of the application, voice over IP, and your video conferencing. This is some of the features that we use even in our campus. Okay, our campus, most of our offices, we have got IP telephones. Okay, there are certain sections of the campus, especially the GP buildings, which we are still using the old PSTN switch network. Okay, but that also, I think, very soon we'll be updating it to IP telephony. Another thing that you will see, UDP does not do reassembly. Remember, in TCP, your data is arranged because of the sequence number that is given at the flag. It will be arranged, the segment, in a proper order and given to the application layer. There's no such thing in UDP, my dear students. If you send it in this order and it comes in a garbled format, it doesn't care. It will just pass this to the application layer. Okay? But remember what I told you. Our priority over here is speed. Okay? Not exactly reliability. There are also specific port numbers associated, okay, with your UDP. For example, your DNS request is on port 53. If you're accessing by using Radius, remote authentication, dial-in user service, usually this is when you use a dial-in modem, okay, then it is on port 1812. So one server can actually serve two clients at the same time using UDP, as long as you've got multiple ports. So both ports are a feature of not only TCP, but of UDP. Okay. Another example is a client getting services from the server using DNS port 53, over here radius port 1812. Okay. So again, the client will assign its own port. Now, we don't care about this port. We don't care about this port. Okay. These are the ports which the client uses to create a session with the server. And the server will serve these. One server, will do multiple sessions through different ports. So you can see that for both your UDP and TCP, port numbers are very important. Okay. Usually, the destination port is well-known or registered port number. So we can say that, your port number 53 is always registered for TCP. 80, everybody knows port 80. It's HTTP. Okay. Without that 80, how can you browse the internet? Okay. This brings us to the end of today's transport layer session. Now, anyone has any question? Okay.